Hi, this lesson is about how to use the law of cosines. So the law of cosines is a formula that allows us to solve for oblique triangles. That means triangles that are not right triangles. And that will be in particular cases of different information that's given. And so we call these case 3 and 4. So we will use law of cosines for case 3, and that's when you're given two sides and the included angle between those two sides, or in case 4, where you're only given three sides of the triangle and not the angles. So law of cosines looks like this formula, which you see in the box. There are three, although they are all very similar. So remember, the lowercase letters represent the sides of the triangle, the capital letters represent the angle. So in this case, we have a squared, that's the side a squared, equals b squared plus c squared minus 2bc times the cosine of a. When you start with b squared, like in the second formula, that's equal to a squared plus c squared minus 2ac times the cosine of b. And the third one is c squared equals a squared plus b squared minus 2ab times the cosine of c. So notice that the side that's being squared at the beginning of each formula corresponds to the angle that you're taking the cosine of. So when I had a squared, little side a squared, I was taking cosine of a here. So the a here corresponds with the cosine of a in the first formula, and so forth. So they're all similar. So we used law of cosines in case 3 to find the third side, because remember you're given two sides and the included angle. And then we will use law of sines to find another angle, and then finally use what we know about that a triangle sum of all angles is 180. So this is a summary of what you'll be doing in order to solve an oblique triangle, where you start with law of cosines and you have case 3. All right, so here's an example. I want to solve the triangle with the given parts: B equal to 87.3, C equal to 34, and angle A is 130. So angle A is between these two sides. That's the included angle. So I have, that means I need to solve for side A first. So I'm going to use the first formula in that a squared equals, and then plug in what you know for B and C, 87.3 squared plus 34 squared minus 2bc, so that's what you see here, times the cosine of A, which is 130 degrees. So when you input this into a calculator, in order to solve for A, you're going to have to take the square root of this whole thing. And that gives you the answer of 112.2. So although you weren't told how to round that side to, because this is a rounded answer, you could use this as your clue as to how to round it. So since those were presented to the tens place, we should also present side A the same way. So now that we found side A, and you know angle A, that means that we can now use law of sines to find another angle. And just so that we're consistent with what we find, recommendation is to find the shorter angle first. So the shorter angle will be, the smaller angle will be opposite the shorter side. So we're going to look for angle C. So we have sine of 130 degrees over 112.2 equals the sine of C over 34. So when you cross multiply, the 34 ends up on the right. So you end up with this equation, 34 sine of 130 degrees over 112.2 equals sine of C. And then you have to take sine inverse of this whole thing because remember you're solving for C. And so sine inverse, you can actually put this into a calculator exactly as I'm stating it. You have to do 34 times the sine of 130 degrees, and this should be in parentheses, divided by 112.2, and all of it goes in parentheses to group it for sine inverse. And that will give you this answer, 34.4 degrees. Just remember, leave your mode in your calculator to degree mode. We want degrees since angle A was presented in degrees. And now that you know that angle C is 13.4 and angle A is 130, we can then solve for angle B by adding those two angles and subtracting it from 130. And so you get that angle B is 36.6 degrees. And so always a quick check is to just look to see that the largest angle is opposite the largest side and the smallest angle is opposite the smallest side. So the largest angle is angle A, and that corresponds with the biggest side of 112.2. Smallest angle we found was angle C, and that's opposite of the smallest side, which is 34. So it's a good idea for you to just do that check to make sure everything makes sense. So here's another example of case 3, where we have two sides and the included angle. So these are the two given sides, and this is the angle between them. So that means I need to solve for side B first using law of cosines. So I used the second formula that was stated above in the box. So B squared equals, and then this is your A squared plus C squared minus 2AC times the cosine of B, and remember angle B is 85 degrees. It's right here. So you have to compute all of that on the right, and then to solve for B, you take the square root of this whole thing. And so we get 0.1374. Again, there were 4 decimal places here, 3 decimal places here. So always round out to what is given in the problem. And since one had 4 and one had 3, pick the greater precision. So pick 4 decimal places. And now that I know all three sides, I'm now going to solve for the smallest angle. And how do we know which one is the smallest angle? Well, our 3 sides are A, B, and C. And so A and C were given, B was computed. So the smallest angle will be angle A because side A is the smallest. So I have sine of A over 0.0845 equals sine of 85 degrees over 0.1374. And again, you'll have to cross multiply. So that goes over to the right, and then you take the sine inverse. So basically, you're going to input this into a calculator, the sine inverse of 0.0845 times the sine of 85 degrees, which means make sure you are in degree mode, divided by 0.1374. And when you do, you get the answer that's stated here is 37.8 degrees. Then you take your angle B, which was given, and your angle A, add them together, and subtract it from 180, and so you get that angle C is 57.2. So now we know all 3 sides and all 3 angles, so you have solved the triangle. All right, case 4 is the case when you are given 3 sides only. And again, law of cosines is used, and again, to be consistent with our answers and the rounding and so forth, we're going to find the largest angle first. Now, which is the largest angle? It's opposite the largest side. And since you know all three sides with case 4, you'll be able to identify that right away. Once you find that angle with law of cosines, then you use law of sines to find another angle. And then the third angle, you add the two you found and then subtract from 180 to get the third angle. All right, so here is your first example of case 4. We have sides A, B, and C being given. Those are your three sides. And the largest angle will be angle C because that's the largest side. So I'm going to use the third of the three formulas that were given originally. So this is C squared equals A squared plus B squared minus 2AC times the cosine of C. That's what we're solving for. Remember, this here is the C squared. So they have to correspond where your side is on the left side of the equation and the cosine of that opposite angle is there. So that there's a little bit more algebra in this type of problem where you're solving for angle C. So first you subtract both of these over along with the 2.917 squared, which is what you see here. And then you want to divide by these three numbers to get the cosine of C alone. So that's why it's in the denominator. So now I have cosine C alone on one side. But remember, you're solving for C, not cosine of C. So you take the cosine inverse of the fraction on the right side. So that's the work that you see here. This can be put into a calculator exactly as you see it, but you would need an extra set of parentheses in the numerator to make sure you group that difference all together. And again, if you're in degree mode, and you should be, you get that C is 69.96 degrees. So now we found one angle, and we're going to find the another angle, by using law of sines. So, so here you have, I'm going to look for sine, angle A. So I have sine of A over 2.331 equals, and then we're going to use the ratio regarding C because I just found angle C. So it's sine of 69.96 degrees over 2.917. And then you cross multiply. So this is what we talked about in lesson 6.5. To get sine of A alone, you will have sine of A is equal to 2.331 times the sine of 69.96 degrees divided by 2.917. Okay, but remember, we're solving for A, so that means you must take sine inverse of that ratio, of that fraction. So it's arcsine or sine inverse of 2.331 times the sine of 69.96 degrees over 2.917. And that gives you 48.65 degrees. And then we take the two angles that we just found, the A and the C, add them together and subtract from 180. And so you get that angle B is 61.39 degrees. So we have found all three angles. The three sides were already given. So that means the triangle has been solved. All right, so let's do another one right here. This is example 4. Just gonna make this just a little bit bigger. Okay, so example 4 has, we want to solve the triangle with the given parts. We have A is equal to 0.29333, B is 0.2635, and C is 0.1538. So the largest angle would be angle B because this is the largest side. So we're going to use the second formula in your law of cosines option. So it's the second one in the box above. So you start with B squared, and then this is A squared and C squared minus 2AC times the cosine of angle B, which is what we're going to solve for. So just like I mentioned before, you need to subtract these two over to the left and then divide by this, and that'll give you cosine of B. But then you take cosine inverse of that fraction, and your answer, again, make sure you're in degree mode, you get that B is 79.67 degrees. All right, so now that I know angle B and side B, I can use law of sines, and I'm going to solve for angle A. So I have sine of A over side A, which is 2.433, equals sine of 79.67 degrees divided by 0.2635, which is your side B. All right, so again, cross multiplying and then taking sine inverse, you get that A is 65.28. So in order to find angle C, we add A and B, which is what we did right here, subtract the result from 180, and you get that side C is 35.05 degrees. Okay, and a good check for all of these problems is to make sure that opposite the biggest side is the biggest angle. So my biggest side was side B. The biggest angle that we computed was 79.67. The smallest side is 0.1538, and that's side C, and the smallest angle we found was angle C, 35.05. All right, so here's a word problem where we're going to use law of cosine. So we have an airline's distance from Denver to Dallas is 660 miles. It is 800 miles from Denver to St. Louis and 550 miles from Dallas to St. Louis. Find the angle between the routes from Dallas. All right, so I drew a picture, but in order to label things a little bit more easily, I let A be Denver, B be Dallas, and C be St. Louis. Okay, and we want to find the angle between the routes from Dallas. So that means we need to solve for angle B. Okay, so let's label everything we know. So you're told that from Denver to Dallas, it's 660 miles. So that's from A to B. That's the 660 right there, and we call that side C because it's opposite of angle C. And it's 800 miles from Denver to St. Louis. So that's this side right here. We'll call that side B because it's opposite of angle B. And you're told that it's 550 miles from Dallas to St. Louis. So that's from B to C. And we call that side A because it's opposite of angle A. So since I need to solve for angle B, you're going to start with the second formula for law of cosines, which is B squared. So that's 800 squared equals the C, here I wrote C squared first. So C squared plus A squared, could be A squared plus C squared, doesn't matter. So it's 660 squared plus 550 squared minus 2 times 660 times 550 cosine of B. And remember, we are solving for angle B. So the work is here below. First, I subtracted these two numbers, so that's why I have 800 squared minus 660 squared minus 550 squared. But then I had to divide by this coefficient, so that's why it's here below, and it cancels on the right side. So you're left with cosine of B equals that fraction. But we need to take cosine inverse of that fraction in order to solve for angle B. And again, in degree mode, that would give you that B is 82.23 degrees. So in a calculator, you need to group this for the calculator so that it knows to square those numbers and subtract them before you divide. So make sure you have those sets of parentheses inside of the bigger set that's here, that's grouping it for cosine inverse or arc cosine. So that's all this question was asking for. It only wants the angle coming out of Dallas. So you don't need to solve the whole triangle, but your answer here is 82.23 degrees. So that's the lesson. Give the homework a try. Good luck.